Today we're going to be talking about the toolkit function f of x equals sine of x, as you can see right there. And right now this is the graph of sine of x, which you can see right there. Just take a closer look at it for a second. This graph looks kind of complicated. It goes up, down, up, down, up, down. It's pretty much the same thing throughout the whole x-axis. This is the graph for it. And each of these points should line up with the graph. As you can see, 0, 0 right there. It goes through 0, 0. Negative 1, negative 0.84, negative 1, negative 0.84, which is right there. So it should line up with each other. Now we're going to talk about the characteristics of this function. The domain is all the x values. So anything that's the x value is the domain. And as you can see, the x values, they go on forever. This is the whole x-axis, so it's going to keep going on forever. Which that means x, the domain is x equals all real numbers, as you can see right there. The range is all the y numbers. And the y numbers, as you can see, they don't go up there or they don't come down here. They only touch 1 and negative 1, as you can see right there. The x-intercept is anything that crosses the x-axis. Anything that touches. So you can see 1 is right there, 1 is right there, there. So there's going to be multiple x-intercepts. But for y, anything that crosses the y-axis, there's none here, until you get to the origin, which is 0, 0. So that will be your y-intercept, which is 0, 0. For increasing, as you can see right there, it goes up. So that's increasing, it goes up, increasing. So there's multiple places, so you'll put yes, multiple. For decreasing is the same thing. As you can see, from there to there it goes down, that's decreasing. There to there, down. There to there, down. So it will be yes. Concavity is like anything that's shaped like a bowl. So as you can see right here, that's a bowl shape, so that's concave up. So that will be concave up. But then if you look here, we also have concave down, which is right there, so it will be up and down. The asymptotes. An asymptote is anything that comes close to a line but never touches. So let's say the x-axis, the y-axis is the asymptote. It will come really close, but it will never touch, just like that. And this, the graph, doesn't have any of those, so that would be a no. Next is the transformations. As you can see, the black right there, the black is the regular toolkit function, which is right there. The one in the blue, it's transformated up 5 places. As you can see, the +5 right there, and all you have to do is move up 5 places. 1, 2, 3, 4, 5, and that's how I got the blue one. And then the red one, you go, it's inside the parentheses, which means move left or right. If you have it outside, it moves up and down. So as you see, this one is -2. So that's going to move right 2, because it's the opposite when it's inside the parentheses. So you go over 1, 2, and that's where it crosses the x-axis, as you can see. Now for horizontal and vertical flips. As you can see, this is kind of complicated. In the black, we have the regular toolkit function, which is right there. Alright, now in the brown, in the light brown, we have the horizontal flip of it. And what you do for the horizontal flip, you put a negative in front of the x, only the x. As you can see right there, it flipped it horizontally. It's kind of the opposite of the regular one. Now, the red one, we moved it up 2 places, which is right there. That's just, we just moved it up 2 places. Now the blue one is a vertical flip of it. A vertical flip, you put the negative in front of the whole equation. So the negative goes in front of the sine of X. And right there you can see that it's a vertically flipped over it. Now the period, midline, and amplitude. So the diameter of the Ferris wheel is 360 feet. So 360 feet is gonna go right here, almost at the top. One revolution is 4 minutes, as you can see right there. So four minutes, it's gonna hit the bottom. The Ferris wheel is gonna be at the bottom. So it takes 4 minutes for the Ferris wheel to do one rotation, which the revolution is a period. So 4 minutes will be your period, because that's when it will go back down. The midline, it's pretty much the middle, in between the highest point and the minimum value. So it will be in the middle, and 360 divided by 2 is 180. So 180 will go right there. And then, so that's your midline. And once you reach 4, you're gonna be back at 0 on the Ferris wheel. And then you put 2 there. So that's gonna be your highest point, which is at 360. And then between 4 and 2, that's 3, which that's going to be at 180, and 1, which is going to be at 180. So you go, and then this is 0. So this is where you start right there. Then you go up a little. In a minute, you're halfway up. 2 minutes, you're at full. You're at the 360 feet. Then at 3 minutes, you go back down to the midline. And at 4 minutes, which is your revolution, you're back down. So right here, this is your period. Your midline, let me connect this. Your midline is this right here. Those points, because that's the middle of it. That's the middle between the greater value and the minimum value. So your midline is gonna equal to 180. And lastly is amplitude. Amplitude is the distance from the midline to the highest point. So that's this distance right here. So it's 360 to 180. If you subtract those two, the amplitude will equal 182. So your period equals 4 minutes, as you can see right there, because that's one revolution. Your midline equals 180, because the midline is the distance between the greater value and the minimum value. And lastly, the amplitude is the value is from the midline to the greater value, which is 360. So 360 minus the midline, which is 180, equals 180. That's all.